All right, so you have your warm-up assignment in front of you. I need you to take a moment and talk with your groups and see if you can match the graphs to the equations. Think about key features that you know. Look at the equations. These are equations you've seen from the beginning of the semester. And again, just talk through as much as you can with your groups. Okay, tell me something about equation 1 that you know. It's a negative. What does negative tell you? It faces down, right? First key feature, which means A's not going to work, D's not going to work, E, F, all the ones that face up are not going to be matched with that. So that's a big thing. This is going to face down. What else do you know about those equations? What kind of form is that in? Who remembers the name of that form? Starts with an F. It's our favorite F word. That's not a bad word. Factor. It's in factored form. Who remembers the zero product property? When you take each term and set it equal to 0 and solve. Do you remember doing that? So when we learned at the beginning of the semester about factored form, I told you that the solutions, so once you solved your equations, that those solutions were x-intercepts of your graph. I showed you what a parabola looked like at that point. It was a while ago, but we talked about it. Is it kind of clicking? Okay, so if my x-intercept is -2 and 3, which graph faces upside down and crosses at -2 and 3? C.
Oh, okay, so the line goes into...
Does everyone see that? It crosses at -2 and 3?
Yeah.
It goes upside down? Do you think you can now go through most of these?
Yes.
Okay, I'd like you to take another couple minutes with your group and see if you can come up with which graph matches which equation. Okay, let's see how we did. I'm going to go through and we're going to talk about whether it opens up or down, and then we're going to look at what the x-intercepts are to match. So number 2 opens up because there's no negative out front. My x-intercepts are +2 and -3, which means you should have graph F. Okay. Number 3 opens up with x-intercepts at 3 and -2. So look at the intercepts are the same between 1 and 3. The difference is the direction it opens, right? You should have graph D. Number 4 also opens up with x-intercepts at 4 and -1, which means you should have graph H. Number 5 opens up with x-intercepts at 1 and -4, which means you should have selected graph E. So far, so good? Awesome. Number 6 opens down with x-intercepts at 1 and -4. What number on 6? You should have graph B. Number 7 opens up with intercepts at 1 and +4, which means you should have graph A. Number 8 opens down with x-intercepts at 1 and +4, but this is graph L. Number 9 opens up. What are my x-intercepts here? 0 and 4, which means you should have graph J. Number 10 opens up. What is my x-intercept for number 10? -2 only. They're both the same, right? So this means your vertex is actually on the x-axis. So that is going to be K. Same with number 11, except it opens down, but your x-intercept is -3, which means it is G. And lastly, you have number 12 with x-intercepts at -4 and -1, and you should have graph I. Yeah. No, I'm just showing the steps so you have them. If you can, in your head, figure out the zero product property for this part, I'm okay with that because that's not like our focus. Okay? Questions on the warm-up? All right. This needs to make sure it gets attached to page 62 in your notebook, but let's move on to the other assignment that you have, or the other worksheet that you have. Okay, so this is the worksheet you should have. This is going to be placed on page 63. It is the second. All right. So in the warm-up, I referenced the zero product property. We now remember what the zero product property is, right? So for this first part, if I wanted to solve for the x-intercepts of the quadratic function, I would set each term equal to 0 and would be able to solve that way. Okay, that's what we just did in the warm-up. But what happens when I look at this second equation, x squared minus 2x plus 1? How would I find the factored form of that to then find the x-intercepts? Okay, listen to my question again. How would I find the factored form of that equation so that I could find the x-intercepts? I would factor.
Oh, I knew that.
Right? You would factor. So let's kind of review how we factor. What's the first thing we always look for when we're factoring? GCF. Okay, GCF is the very first thing you should look for. If GCF works, great. If it doesn't, then what's an option?
Super X. Yeah, X.
Okay, so X would come first. And how do we know when we're going to use the X? How about if A is equal to 1, right? Since we know that first term is A. So if A is equal to 1, we use the X. Another option is the super X, and when do we use that? A is greater than 1. Now remember, we can use the super X for any of them, but you have to use it if A is greater than 1. What was another way we factored? There's one more you should remember. Difference of squares. Do we remember difference of squares? This is when you had something like 0 equals x squared minus 9, where both are perfect squares. There's two terms and there's a subtraction sign in between, and you have x plus 3 and x minus 3. Do you remember that? You also have a final in a couple weeks, and factoring is going to be a huge part of that final. Okay, so looking at this equation, how would I factor x squared minus 2x plus 1? The x, right? So on top of the x is a times c. A is 1, c is 1. So on top is 1. What's on the bottom? B, which is -2. What two numbers multiply to 1 and add to -2? -1 and -1. Now make sure you check that. -1 times -1 is 1. -1 minus 1 is -2. From here, and this is where a lot of you messed up when you were factoring, you need to go to factored form, which is this. So you should have 0 equals x minus 1 times x minus 1. Once it's in factored form, that's when you set it equal to 0 and solve. If at this point, so I need you to write it in factored form, if at this point you don't need to do this and you can do it in your head, I'm okay with that. Because I know x minus 1 is going to equal 0, which means x equals 1. That amount of work is okay, but you do need to write it in factored form, because those of you that did not write it in factored form and tried to go straight to the answer got the signs wrong because you forgot that you were actually solving something. Okay? We remember all of that? All right. So there may be a time where you have a quadratic equation and you're asked to graph. So what form is this quadratic equation in? Standard form. And yesterday when we were in standard form, what did we have to find first? You had to find the vertex first, right? And what did we use to find the vertex? Negative b over 2a. That still applies. When we use negative b over 2a, what did that actually find for us? So h, or the x value of the vertex, right? And then we took h, or that value, and plugged it back in to find y. Agreed? Okay. Now, instead of using a table of values, in this case for today, we're going to factor and use intercepts only to graph. So you still have to find your vertex because you have to know how high or low your parabola goes. And then we're going to factor and find our I can't even talk right now. Factor and find our x-intercepts and use just those 3 points to graph. You won't have to use a table of values. Okay? The reason I show you a table of values is because not all equations are factorable. And I probably won't force you to do one or the other when it comes to standard form. So if you really like to factor and want to solve that way, that's fine. If you prefer to use a table of values, then I'm okay with that as well. But for today, we're just going to practice the factoring and finding the x-intercepts. Okay? So first thing we need to start with is finding the vertex. So let's identify our A, B, and C. What is A? 1. What is B? 10. And C. Okay, I don't really need C, but it's good to practice that because some of you are going to have to take the retake for Mod 11, which is on the quadratic formula. Plus, all of you will be taking a final exam in a couple weeks, and we'll need to know those values. Okay, if I plug it into negative b over 2a, I get negative 10 over 2 times 1, which is 2, right? Negative 10 divided by 2 is negative 5. So the x value of my vertex is negative 5. But I also need the y value. So just like we did yesterday, y equals negative 5 squared plus 10 times negative 5 plus 16. As I was helping some of you with homework yesterday, you messed up because of positives and negatives. You need to be very, very careful. Negative 5 squared is 25. 10 times negative 5 is negative 50 plus 16. So 25 minus 50 is negative 25. Negative 25 plus 16. Negative 9. Everyone agree with that? Okay, so my vertex is at 5, negative 9. I know that is 1 point on my graph. I'm going to factor this equation to get my x-intercepts. So which option for factoring should we use?
Are you doing the x squared one?
Just the x, because the number in front of x squared is 1, right? So if I factor using the x, what goes on top? 16. A times c. 1 times 16 goes on top. This is A times C. What goes on bottom? 10, which is your B. So you're looking for two numbers that multiply to 16 and add to 10. 8 and 2. 8 times 2 is 16. 8 plus 2 is 10. Okay. From there, we're going to factored form. We have x's. X plus 8 times x plus 2 equals 0. What are my x-intercepts? Negative 8 and negative 2. Now, when we're talking about x-intercepts, we're talking about a point on a graph. Because right now, this is more an equation of a line, right? So my x-intercept really is negative 8, 0, because it doesn't go up any on the y-axis. And it's negative 2, 0. Intercepts are always points on a graph. Because if I plot negative 8, 0, that's this point right here. If I plot negative 2, 0, that's this point. And then I also need to plot my vertex. Negative 5, negative 9. Can you tell me any key features about this graph? Like what the orientation is? It should be up. And then what's the shape? No change. Okay. Now, we only have 3 points to deal with, so we're going to just sketch as best as we can. And we're going to draw those in. Do you think you and your table can try number 2? Yeah? Okay. So, find your vertex, factor, sketch your graph. Okay, so let's see how you did. So A should be 1, B should be 4, C should be negative 12. When I plug it into negative B over 2A, I get negative 4 over 2, or negative 2, which wasn't the issue, right? It was when you plugged it back in for Y that you got a number larger than the graph. So this gives you 4 minus 8 minus 12, which is a negative 16 for your vertex. You got that far though? Okay. We also need to factor. I'm using the x because the a value is 1, so you should have negative 12 on top, 4 on the bottom. Two numbers that multiply to negative 12 and add to 4.
6 and negative 2.
6 and negative 2. 6 times negative 2 is negative 12. 6 minus 2 is 4. In factored form, I get x plus 6 and x minus 2 equals 0, which means my x-intercepts are at negative 6 and at positive 2. So at negative 6, 0 and 2, 0. So for this one, because the negative 16 won't fit on the graph, I'm going to use every box as 2, which works out for me because everything's even, right? So if I go by 2s, I'm going to negative 2, 16. So each box counts as 2. 2, 4, 6, 8, 10, 12, 14, 16. So I should be, if you go by 2s, I'm technically at negative 1, negative 8, right, if I'm going by 2s. Now, negative 6 would be 2, 4, 6, and 2 would be here. Now, because of scaling, my graph looks a little, and it's a little wonky, but my graph looks a little skinnier than normal, right? Because I didn't go by a single box. I will make sure that on a test that everything fits on your graph. If it doesn't, for homework, or in this case, notes, sketch it and do the best you can on it, okay? Questions on those front two? Okay, we have 2 more to look at, and we might just look at one of the 2, depending on how we feel. What's the difference between these 2 problems and the first 2 we looked at? You have to use a super X, right? Again, this is going to help you with your final exam because a huge portion of your final is factoring. So let's start with the vertex. We'll do this one together. So A equals 3, B equals negative 26, C equals negative 9. When I plug it into negative B over 2A, I get a positive 26 because it was already negative over 6. Okay. It's a fraction. So let's reduce that fraction.
13 over 3.
13 over 3?
I did mental math.
It's not a great fraction, but can we do it? Yes, you can. What else? 13 over 3 is also what? Oh, that's a 2, not a 3. Okay, 4 1/3, 4.3. So when we graph, we'll go to 4.3 in the graph. Okay, this is going to be your favorite part. We're going to plug it in. Yes, Make it into a mixed number. So you divide by 3. So 13 divided by 3 is 4. There's 1 left over because 4 times 3 is 12. There's 1 left over, and then you keep the denominator. But when it's a mixed number and you're going to improper, you multiply the bottom and the whole number, and then add, and then keep it over the denominator. Okay, ready to plug this in? I know you guys love me. It's your favorite. Here we go. You can do it. We all can do it. We're going to not use mental math because that would be a bad idea on this problem. One step at a time. Are we ready? It'll be okay. I'm going to do it with you. What do I do first? The exponent. 13 over 3 squared, right? So 13 squared is, 169. 3 squared is 9. And that's all I did was square it, and that's all times 3. Okay, watch. Things are going to work out kind of nicely. Let's simplify that before we go on. Do you agree that that's technically 3 over 1? Yes, right? Now, when you are multiplying fractions, you are allowed to cross-cancel or cross-simplify. So I can say 3 goes into itself once, and 3 goes into 9 3 times. Are you okay with that? So really this fraction is 169 over 3. I'm going to just leave it like that for right now. That's this first part. I promise they won't always be this bad, but you do need to know how to deal with fractions. Okay, so if 3 is the same as 3 over 1, then I can say it's 26 over 1, right? Now, does 3 go into 26? No, so I can't do anything there. Nothing simplifies here, so I'm going to multiply across. Negative 26 times 13 is a negative 338 over 3. Right? Everyone okay with that? Okay. Now, 9 is the same as 9 over 1. So I just have that on the bottom. But what's the problem? Can I do anything with those fractions? No, why? It's 9 over 1 and doesn't have a common denominator. So my common denominator between all 3 of these would be 3. So if I multiply this last fraction by 3, I really get negative 27 over 3. Now I can add all the numerators. So in my calculator, 169 minus 338 minus that 27, and it's a big number, you get 196 over 3. Okay, that really sucks to graph, because you want to know what negative 196 over 3 is? 65.3. That is for sure not fitting on my graph. Okay, so negative 196 over 3, I'm going to write it as my vertex. And I'm obviously 5th and 6th period. I apologize. I know I'm not there with you. Please stop freaking out. It'll be okay. All right. Now, I'm probably not going to make you graph this one because it's crappy, but I am going to make you factor it because factoring is not as bad. So we said we would use what? The super X, right? I'm going to come down here because I need some more room. So what goes in, or what goes on the top of the super X? Negative 9 times 3, A times C. So 3 times negative 9 is negative 27. Agreed? What goes on the bottom? Negative 26, your B term. Does anyone remember what goes here?
What goes at both?
Your A term and your variable. Your A term and your variable. Now we have to find two numbers that multiply to negative 27 and add to negative 26. Negative 27 and 1. Negative 27 times 1 is negative 27. Negative 27 plus 1 is negative 26. Who remembers the next step from here? Reduce any kind of fraction. So 3 goes into itself once. 3 goes into 27 9 times. Can I reduce here? No? So factored form is x minus 9 times 3x plus 1 equals 0. So what are my x-intercepts going to be? X equals 9. So really 9 comma 0. Now I'm going to write this one out because this is the one we struggle on. How do I get x by itself? Subtract 1. So 3x equals negative 1. Divide by 3. X equals negative 1/3. So that x-intercept is negative 1/3 0. I'm not going to make you graph this one because it's bad, but you do need to practice finding the vertex and getting the x-intercepts. Okay? All right. I do want you to try the fourth one. I don't really know what's about to happen. It could be, yep, it's definitely going to be a fraction. But I want you to try it with your group. Okay? You can do it. I have faith in you. And then if you, for whatever reason, can't get the vertex, you can at least try to factor. Okay? You have a couple steps that I want you to try. Yeah. We will finish tomorrow, but on your homework that has been passed out to you, I want you to attempt as much as every single problem as you can. So, finding the vertex, factoring, graphing if possible. Okay? My expectation is that you try, and then we will go over it tomorrow.